Hey everyone, and welcome back to video number 4 in this series on making a shooter RPG in Godot. This video is going to cover two main aspects, adding projectiles and adding in enemies. And I'll warn you that this is a little bit heavier on scripting than the other videos. You've learned a lot about Godot so far, so now it's about leveraging its scripting capabilities. And as a result, I think it might be better to just follow along with this video maybe, instead of pausing, adding the code in, and then resuming the video. So if you do want to follow along line by line, you can resume from the video 03 folder. Otherwise, it might be a good idea for you to just diff the contents of the 03 and 04 folders as we go through this video. We've sort of foreshadowed one of the issues that you might run into here, which is whether you should use a rigid body 2D or a kinematic body 2D. What we've talked about is that we want billboarding, which means that we need to set the object's rotation. But if it's a rigid body 2D, then you don't control it directly. So as soon as you set its rotation, the next frame it's going to reset itself. So we have two solutions to this. One is a hack, which is to just keep setting it every single frame so that it never has a chance to reset itself. This probably would have some unintended consequences, and I don't know for sure what they would be. And then the second option that we have is to use a kinematic body 2D. This would let us control the rotation directly, but we won't get that bounce effect that I had shown you in an earlier video. Let's cover that again here. So these aren't synced or anything. This video has a rigid body 2D, and you see that bounce effect that I'm talking about, where they're bouncing off the trees. If you wanted that with a kinematic body, you would have to code something like that yourself. And then the other two videos, which I'll just play them all again, this had move and collide, where the projectiles are hitting the tree and stopping, and this has move and slide, which is what we coded here. So these are the kinds of things that add to the development woes as we go through any project. You have a decision, you don't necessarily know the consequences, and you have to move forward at some point anyway. So in my mind, this is, do you want to code something quickly? Like I said, that hack from earlier, I used that in the original code for this game. And it was pretty fast because I didn't have to think too much about it. But in preparing this course, I wanted to research all of the potential options. I ended up recoding this a lot of times. And what I settled on were these kinematic body 2Ds as a solution. But in the end, you should really just ask yourself, how much does this matter? These are projectiles in a video game that probably won't see the light of day because this is just a test project. So you could move forward with whatever you want, and feel free to try different things from what I suggest in this video. All I want is for you to feel like you're capable to make these decisions yourself, and hopefully not be as burdened as I was by them. I know I titled this Woes. So let's get to it. We'll start by making a projectile. This is the same process as making a character, so I just open up the Archer scene and save it as arrow. Now we're going to remove the script because we don't want a player controller on our projectile, and we're going to change the sprite to an arrow. This arrow has to be facing up for the calculation that we'll be doing later. If you did not have an arrow that was facing up, you could pick a different one and you could use the rotation property on its transform to make it face up, or you could modify the sprite sheet. But since we have an arrow that's already facing up, let's use that. I'll talk more about that later. And then we want a collider for this. This one can just be a capsule, and we just make it the right size. There we go. So we save that. Do the same thing for your warrior and mage projectiles. So I'm going to save an axe here. And our sprite, this one's a little bit harder to locate. The sprite sheets are gigantic, so I'm going to paste in the coordinates, 864. So there's our axe. For this, we will use a circle shape. This one does not need to face up because we're going to have this projectile rotate as it's flying through the air. So it doesn't really matter where it's facing. And we'll save that one. And then we'll save the last one will be fireball. And these coordinates are over here. Again, it doesn't really matter what you pick as your projectile. So you could pick you could be shooting snakes if you wanted to. We do need the origin of the scene to align with the center of the projectile. So we'll move that, and then we will resize the collider over here, and we'll save that. I said this video is going to be script heavy, but we've done the easy part, and now it's going to be script heavy. We're going to go to player controller now and make our character shoot the projectile. So we're going to add code to several different spots here. The first bit is the member variables. We have fire cooldown, which when this hits 0 or lower is when we'll be able to shoot. We have fire reset, which is what the cooldown is going to get reset to after we shoot. So basically it's going to be like a timer that goes down to 0 and then starts up at 0.42, goes down to 0, counts up. And so that lets us shoot every roughly half a second. And then should fire operates the same general way that velocity and camera rotate delta do, where we'll set this at the beginning of our unhandled input function and then use it to figure out whether we should shoot. So to get to our unhandled input function quickly, we could just click this at the bottom left, and then we will add in our new code. So we have should fire being set to false at the beginning here. And then if we have pressed the fire key, we can set it to true. Now you could lump all this into one line because this is returning a Boolean, but just for the sake of consistency, I've put it as its own if statement. We do need a fire key. So we'll go into input map, we will add fire, and I will have this be a mouse button for the first time. So I'm gonna pick all devices. I don't totally know why you'd ever have more than one mouse attached or what that would mean, but we'll just say all devices, left mouse button. So we'll add this, and then we will go into physics process and make sure that we are subtracting our delta from fire cooldown so that we can get to shoot. And we have code here that says if should fire, then fire projectile. So now we just don't have this fire projectile function, which it's detecting for us and highlighting red, and we'll add that in. So fire projectile says if we are on cooldown, just immediately return, so you can't shoot. But if we're not on cooldown, then print out firing. And this is because we don't want to spend too much time coding without testing. So let's go try this out. We're going to click, and we see firing as I'm holding down the left mouse button over here. And that's the foundation for our code. Now that we know that it's working, let's delete our print line here, and let's add in real code that is very similar to what we had in gameplay. I'll actually show you the code. What we had in gameplay for instantiating a player and then adding it as a child. So what we're doing over here is we are loading in the arrow, instantiating it, and adding it as a child. And remember, we're adding this as a child to the player. So what's going to happen when we run the game and start shooting projectiles now? Well, since it's a child of the player, it's going to get added at the player's origin. And I actually just added something like 8 different projectiles. I don't know how long I held that down for. But if we go to the remote scene, we can see a lot of kinematic bodies got added at the bottom of this. This could actually be kind of a cool effect. If, let's say you're making a game like Mario Kart and you wanted there to be 3 green shells rotating around your character, you would have the projectile be a child of your player. And that way they're in the player's coordinate space. But we want the projectile to be sort of in world coordinates so that it shoots from the player. And as I move, it does not adjust the projectile's coordinates. To get the projectiles to show up in world space, we will emit a signal. And this is just like rotation. We're saying, hey, I rotated, and whoever cares can listen to it. We're going to say the same thing, hey, I just fired a projectile, and whoever cares can listen to that. And in our case, it's going to be gameplay. So this code that we had in fire projectile, we're just going to change to the signal and cut this out of here and move it into gameplay as its own fire projectile function. So here's our new function for this. And then we need code that listens to this signal. So same thing that we had before. We're now listening for fired, and we're going to need the onPlayer fired function, which is here. Let me tab this in correctly. Okay, so now let's look at the whole thing. We are listening for the signal. We're calling onPlayer fired. This is just a quick shortcut for fire projectile. You might wonder, why didn't you just put fire projectile in here? And I don't tend to do that because other things might call fire projectile, but probably nothing else is going to call onPlayer fired. So I like having that little layer of separation. Again, what do you think is going to happen when we do this? So now we're adding the projectile to the game. So when I click this, we see the arrow show up at the origin of the game world. And by the way, I think it's a good idea to run through that thought process of what's going to happen here, because it really tests your understanding of, do I know how Godot is going to act? Are my assumptions validated or are they wrong? We clearly don't want the arrows to be at the origin here. So let's go change our code. Let's make it so that fire projectile passes the player into the fire projectile function. And here we will add that in as the firer of the projectile. So before we add the projectile to the scene, let's position it at the firer's position. And now let's just run that code. So now all we're doing is pretty much the same thing as we had before, but now that the projectiles are in world space, we can see that they're getting positioned and then staying there. They're not moving with the player. If these were rigid body 2Ds instead of kinematic body 2Ds, we could give them a linear velocity as the starting force, and they would just know how to move through the world automatically. But we made them kinematic body 2Ds, so the way that we have to move them is via a script. So let's go to our script folder, right click, go to new script, and we'll call this one projectile. And then I'll open up that file and we'll paste in our script and cover what this is doing. So first of all, TTL is short for time to live. It's just how long this projectile is going to last. You can name this whatever you want, of course, but then you need to replace the other instances of it. So here we're saying that this is going to last for half a second. And then the speed is going to be in pixels per second. So 440 pixels is how fast it's going to move. When we initialize it, we're going to initialize it with its firer to set its position. And then every physics tick, we're going to call move and slide just straight up. And then if it dies, we're going to free the node. And we do this via queue free. What this is saying is we want to remove this thing from the scene tree and then dispose of it to mark the memory as free. So there's no automatic garbage collection. There's just reference counting and then calls to free. And you can call it yourself like what we're doing here. And the queue part of freeing it is saying don't do it until the end of the frame. So now let's go initialize our projectile. So we're going to do projectile.setScript, projectile script, and we're going to load in that code. So this is a GD script, preload, res scripts projectile. And let's call init on it as well. So init with the firer. Now we don't need the firer position over here because the init function that we have in projectile is going to set that for us. Let's see if I got that right. So yeah, now we're shooting projectiles and it's a little bit hard to see, but they're living for half a second. So they are actually dying before they make it to the edge of the scene. It's a little bit more obvious if I move as I do it. We obviously have at least one problem here, which is the projectile is always shooting up regardless of where we're facing or what we're trying to do. There's a second less obvious problem, which is that the projectile is not colliding with anything. So let's go fix both of those. To start with, in init, we'll do what we have done before, which is to set the collision layer and mask. So this is considered to be a player projectile for now, and it's going to collide with, we can put this on different lines if we want to, the walls of the world and enemies. So now let's run just this code, and we'll hopefully have fixed one problem. So we're still shooting over the pits of the world, which is water, but when we get to here, it is moving and sliding around the tree. Before we fix the other problem, let's do something a little bit interesting here, which is we will change our firing rate to 42 times what it currently is. So it's the exact same code other than the firing rate. So now we should shoot very quickly. And so we see our line of projectiles. This is actually really nice for testing because if we wanted to test collisions, for example, we don't need to wait half a second for a projectile to shoot. And now let's try modifying that collision code a little bit. So we have move and slide. Let's try move and collide. And move and collide does not take delta into account for us, so we will need to multiply by the delta. Move and slide does. So we're still shooting and it looks pretty much the same, but now when it hits a tree, we have different behavior here. We can take this to any extent that we want. So let's paste in this code and let's see what it's doing. It is saying rotate the up vector by sign of something. So sign varies from -1 to 1 in a smooth way. And we're saying that it's going to go os.get ticks in milliseconds. This is basically just the system clock, and we're dividing by 50 to get a different waveform that we have here. And so now we see that we're shooting in a sine wave. So this stuff can be really cool. You might want to add an ability into the game that does this, or makes just a single projectile shoot in this fashion, and maybe it's very large. And just experiment and see what you can make. I reset the code to what it used to be, so now we're always shooting up. And we want it to always shoot where the mouse is. So let's add in a velocity direction member variable, which we will compute based on where our target currently is. And the way that we compute that is linear algebra, except that Godot handles that for us with this direction too. So we have where you are, and we have where your target is, and it's going to draw an arrow from point A to point B, and that's where we'll move. So instead of vector2.up here, we're going to replace it with velocity direction. And now we're going to move to our target position every frame. So we just had to fix one more thing, and that's passing in this target position. And that's gameplay's job. We're just going to specify that as the mouse position. So let's go try this out. We have a very skilled archer here because now they can shoot arrows that are not facing the direction that they're moving in. So let's fix that too. That is relatively easy to do. We go back to projectile and we set our rotation to be the up vector rotated to wherever our velocity is pointing us. And this is why I had you make your arrow scene or your fireball scene look like this, because this is why it's set to vector.up and not why it's set to vector.right or something. You could have made this face right, and then you just would have needed to modify the script to reflect that. So now when we run this, our arrows should shoot in the proper direction, and it looks good. That's it for our basic functionality. We now have our character shooting a projectile at exactly where the mouse is, and they're rotated well. But we've written this in a very inflexible way. You can see that this was hard-coded to say that it's a player projectile, which means it has to collide with enemies. We also, in gameplay, forced it to be an arrow, even though we made an axe and a fireball, so our warrior is also going to shoot arrows. I'm going to cover what the completed code looks like, because otherwise there would be a lot of moving through files and changing small things. Let's start with the change we made to constants. We manifested it in an enumeration that corresponds to our various projectile scenes, so arrow, axe, and fireball, and this is just called projectile types. So then each character can manifest its own projectile. An archer shoots arrows, the warrior throws axes, and the mage casts fireballs. And each projectile has its own set of parameters that correspond to it. So arrows shoot very quickly and they last for a long time. Axes are the opposite. And they also correspond to their scenes that we made. So scenes arrow, scenes axe, scenes fireball. And that's it for the constants changes. The nice thing about this is that by having everything in one place, let's say we wanted to manage the balance of the game. And we said, you know, arrows are a little bit too fast, so let's set them to 400, and axes are a bit too slow. We can do all this in one spot without having to hunt through the code and change them everywhere. Projectiles, especially in a game like this, can eventually have lots and lots of options for controlling them. We saw a couple of them in constants there, time to live and their speed, but eventually we might want things like damage and whether they're rotated. So I made a class called projectile params, and this is sort of like a C struct in that it just takes in a lot of different properties, some of which are required and some of which could be optional eventually, and it'll save them off. And this way we get type checking on these. What we could have done is just pass in a dictionary every single time that doesn't have this type checking and just save it into the projectile and rely on duck typing, which we'll talk about later. But that's a little bit less safe because we can't check any of that at build or construction time. Moving on to player, what we used to have here was just emitting a signal that we shot a projectile, and game had to figure out what it was. Now that we have projectile params, the player can set itself as the firer, can specify its class's projectile type, and can pass in the mouse position itself. And this way, the player could figure out how to position these projectiles. So like I said earlier, we could use a sine wave or something. We could pass all of that in through projectile params and have projectile know how to treat that code. That way gameplay doesn't need to know it. It's just going to pass along these parameters to the projectile. And that's exactly what we see in gameplay. Now, fire projectile has this parameter set plumbed through it. So we go right from the signal down into on player fired, we have projectile params, and it makes it all the way into the projectile's init function, which brings us to the final resting spot for this, which is projectile itself. It takes in params, and it just reads the same properties it would have read back when this had 2 parameters to the constructor. Now it only has 1, which is a dictionary, and we can read all of the code exactly the same way we used to. There's one other tiny change that I made, which is to set the rotation just once here in the constructor. And what we have as a result is that now the warrior will throw axes. They're not being rotated, and the mage will shoot fireballs, and they're not being billboarded. So there are still some changes we want to make here. There is one more thing I want to point out before we get to those changes, and that's this function. This is the first time we've ever used underscore init. The function we've been using up until now just didn't have that underscore, and there's a very important distinction between them. Our init function doesn't have the underscore is a convention that we just made up. And like I said, could have been called install or construct. We could have named it anything because we were the ones defining it and calling it. But underscore init is called by Godot. And the reason we couldn't use it before now is because we were always doing something like .instance or .set script, both of which will call init for us with no arguments. This time though, projectile params never exists as a script on a node. It only exists as a script that's sort of intermediate here. So player, for example, makes one and then emits it. It's not adding it as a child. If we were to instantiate a scene, like I said, that init function will get called automatically, but we're calling it here by doing .new, so we can specify what parameters it's going to have. If that doesn't make sense, I do suggest looking through the documentation for how these functions works and just kind of experimenting a little bit yourself. Unfortunately, there's not a whole lot here, but if you try out .instance, .setScript, .new, you'll see what I'm talking about. Now onto those changes that I mentioned. We want the warrior's axe to rotate. So we are going to go hunting and pecking through code right now, and we're going to set just on the axe a rotation speed of 7. So we'll save this, and then in projectile params, we want to be able to specify a rotation speed. So we will specify a member variable here called rotation speed, and then we are going to pull this data from projectile info from constants. But it's an optional value, so we'll use our function that I wrote, get optional value. I heavily commented both get required value and get optional value down here, so you can read through those to see how they work. So here we have a rotation speed, and since it's optional, our default is going to be set to 0. So that's our final parameter there. Then in projectile itself, we are going to have a rotation speed that we're going to set. We're going to pull it from the projectile parameters, just like before, and then in our function, we are always going to add our rotation speed. And when it defaults to 0, that's essentially going to be delta times 0, so we just won't be modifying it at all. Now let's try this out. We're going to go to our warrior, and I'm going to throw axes, and we can see that yes, they're rotating in the air. What we should also test is what happens when I use the archer. Now if we coded this wrong, we would see arrows be rotating as well, but they're not. If we wanted them to rotate, although this would look a little bit silly, we could certainly add this in and test that our system is working there too. It's not like we made something that's specific to axes. So now we are shooting rotated arrows, which yes, looks very ridiculous. The mage's change is a little bit hard to see because of how fast the fireballs are shooting. So let's slow it down a little bit. We'll set the speed to 5. So they'll move very slowly and we'll have them live for quite a long time. And that way we can see what's going on here. So we shoot fireballs, and you can see that they're rotated just like how arrows are rotated. And as I rotate the camera, they're not billboarding themselves. So we want to fix both of those because I consider them to be problems. You might like the style of that, in which case you don't have to fix this. But the point is to show off our flexible projectile param system. Just like with our axe, we're going to set a property only on fireball. And this property is going to be is billboarded true, which means that our projectile params will also need to be updated. And we're going to have two properties for this one, and this is a little bit unusual. So we have a Boolean representing whether we're actually going to read this billboard rotation. And the reason why we have to do this is because with our optional values, we can't just set them to null. So let's say we tried to do that. Let's say we set billboard rotation equals null. It will give an error here, and it says you can't assign a float to null. And this is because these aren't boxed parameters if you're used to something like Java. If you have a static type here, you cannot have null in that value. This is at least as of Godot 3.2. So we need to do one of two things. Either we represent this with a Boolean, like what I've decided on here, or two, we just drop the type. When you drop the type, now you can change its type at will. And null is allowed, and then setting it to a float would also be allowed. So we could set this to 5.0 before or after it. Godot will never complain and mark this as an error. I've undone that code about the typing, so now it's back to a Boolean and a float. I just want to explain the design behind that. We still need to finish this code, so we'll paste in this. Is billboarded will now get set to an optional value. So for everything other than the fireball, it'll just be set to false. But for the fireball, it'll be true. We are not actually setting billboard rotation here. And for the reason why, let's consider who is setting the projectile params. It is actually the entity doing the firing. And the entity firing a projectile doesn't necessarily know what angle that should be set to. The game does. And actually the player does too, but it might not be that way in the future. Maybe we'll have an enemy shooting a projectile, and unless it has a reference to the player, it won't be able to pass that in. So instead, what we need to do is set this through gameplay. It's very easy to do. We just call into that member variable and set it to the player's rotation. And then we modify our projectile to use this property. So we have is billboarded here, and we set it to our parameter that we have. And then if we have billboarded our projectile, then our code is going to look like this. this actually will mess up due to mixing tabs and spaces, so I'm going to fix that a little bit. Okay, let's look at this code. So we are taking isBillboarded from the projectile params, which we had just made in that class. And then if we are billboarded, we set our rotation to the passed-in rotation that we should have, which is the camera's rotation, which is how objects get billboarded. So now when we shoot those fireballs, watch what happens. So now no matter where I'm shooting them, they're always facing up. But then when I rotate the camera, they're no longer billboarded. The only other thing in our world that's being manually billboarded is our trees, and that's what's happening here. When we get that rotated signal from the player, we're iterating over all of our obstacles and we're rotating them. How could we rotate all of the projectiles? Well, we can use a new concept, at least to this video, for Godot called groups. So let's say we go into constants and we make a group name. Groups are just tags on an object, basically. So you get them essentially for free. And we have a group name here. What if we tag our projectiles with it? So we add all of our billboarded projectiles to this billboarded group. Then what we can do is we can change our unrotated code to look like this. So I'm going to get rid of the code that we had already, and we're going to get everything in the billboarded group and we're going to rotate it. So let's go try this out. So I'm going to shoot some fireballs here in every direction, and now I rotate, and now I see something interesting. So the fireballs are correctly billboarded no matter how I rotate, but the trees aren't because I commented out this code. And the reason why is because I don't want two separate iterations in this function. What if we just added the trees to this group? And we can do exactly that. So we don't have a ready function already. So let's go add one in. And what we're doing is very similar to what we had over here. We have the nodes in the world maps obstacles, so that's exactly the same line. We have for child and nodes, so that's exactly the same line. And then instead of setting their rotation, all we're doing is adding every tree to that billboarded group. Again, this is just a tag. So what we're saying here is, as soon as the game is set up and it's in the scene tree, let's add all of our trees to the billboarded group. Every time we make a projectile, let's add the projectile to the billboarded group if it's supposed to be billboarded. And then when the player rotates, that signal can now just iterate over every single thing in the group. I actually chose the wrong class there. I should have chosen the mage because the archer doesn't have billboarded projectiles. So yeah, now we rotate and everything is facing the same rotation as the camera. Before we undo this speed change to these fireballs, let's set isBillboarded to false to make sure that this is working correctly. So here we're going to say isBillboarded is false, and this will let us know if that property was set up. So yeah, now we see them shooting in just all sorts of directions, and when I rotate the camera, they're not billboarding themselves. So that means that that property is working as intended. And there's one thing to point out about the solution we did here to both rotation and to billboarding, and that's that there's some duplication in the code. We see that rotation speed is pulled out of params and isBillboarded is pulled out of params. So why not just delete these entirely and just always pull these from params? So let's search for rotation speed, and we'll set that one to be pulled from params. So now we don't need this one. And then isBillboarded, the same thing. We'll just check it from params. This will work, and it's a little bit cleaner, but there are a couple of things to consider here. So our projectiles are still shooting. One is that parameters are potentially going to get reused depending on how the caller uses them. So you'll have to be careful not to do that. So for example here, let's say we were to shoot 20 of these projectiles. So we have for I in range 20, just iterating over this array of 20 things, and we're going to fire using the exact same projectile params. So what will happen here? Well, we see arrows hardly shooting anywhere at all. And why is that? Well, let's go back into projectile for a second. We see params.ttl minus equal delta. So every fraction of a second that a projectile is alive, it will subtract how much time has passed. And we said we wanted these to live for a second or 2 seconds. It doesn't really matter. We have 20 projectiles though, and now they're all using the same params. So that means we're really multiplying delta by 20 here, and that's why the projectiles aren't living for very long. If we were to set this to 200, we probably wouldn't even really see the projectiles. Yeah, so you can see them just kind of flash on the archer really quickly. So that's something you have to be careful about. The fix for this is actually really, really simple. We would just move this for loop up here and make sure that we're instantiating with different projectile params every single time. So if we do this, now we'll see just it look like a single arrow. It's really 20 different arrows. but they're stacked on top of each other. We have projectiles, but there's nothing to hit. So you know the drill. Let's add some enemies. We'll start by opening up our archer scene, and we will save this as rat. I'm going to remove the script from it. I'm going to modify its picture and try to find the rat. There it is. And then we will just set a really simple circle collider for it just to make this fast. So there is our rat scene. Let's add a rhyming enemy. We will add the bat scene. And the bat, I am not going to bother trying to find its coordinates. It is 140896. And again, circle collider is mostly fine. When you're doing this, I would hope that you're making this look a little bit better or adding more collision shapes, maybe to cover the wings if you want to, but I'm just trying to demonstrate these, so I'm going through them pretty hastily. Just like with our players, when we added these for the first time and we had character class names and character class info, we're going to add enemy names, rat and bat, and enemy info. So we have enemy names.rat and it's pointing to the right scene, and same thing with the bat, it's pointing to the right scene. Let's just get the spawning logic down and we can worry about the AI later. So here's a view of our world map. The way that I'm going to get spawning working is we're going to make an area 2D that represents the spawn zone. And this is where monsters can spawn. So we might spawn a bat at the upper left corner, we might spawn one in the middle. Then we're going to dynamically create a slightly larger area around it called the trigger zone. And what this is going to do is when the player is moving from the north down into this trigger zone, as soon as they enter this, it's going to spawn monsters in the spawn zone. This area between the trigger zone and the spawn zone is roughly about a screen tall. So that means that as you're moving down in the world, you won't be able to see the monsters spawning. If we were to contract this trigger zone to, let's say, just a tile around the entire spawn zone, then you might step onto the trigger zone without knowing it, because again, these are just invisible to the player. You would step into the trigger zone and then immediately see a rat appear in front of you. And that'd be a little bit jarring in this game. Make a new scene and add a node 2D by clicking 2D scene. And we're going to call this monster zone. And I'm going to capitalize the Z there. Underneath that, add an area 2D. The reason that we're using an area 2D and not a kinematic body or a rigid body is because all we care about is collision. There's no physics with any of this. We just want to know, did the player enter this region? And the region is going to be defined by a collision shape 2D in the shape of a rectangle. And we'll give the rectangle a little bit of size. We're zoomed in to about 1000% right now. So we're just going to give it a little bit of size to make it easier to see when we're zoomed out to a normal level, just to make these drag handles a little bit more obvious. Save this as monster zone. And then in our area 2D, let's set a collision layer of nothing. This is for no particular reason. Remember that as long as its collision mask indicates that it can collide with players, which we will set right now, that's the third bit, that we're fine. So what we could have done, and you can still do this if you want to, you can go into your project settings and you can search for physics and you can name the 7th layer something like monster zones and you can categorize the monster zone there. But you don't have to do that because the monster zone can just know that it collides with the player, and that'll be that. In order to spawn monsters, we need a script. So we will attach a script to our monster zone. It has a totally fine name, but it's in the wrong spot. So we'll put it in the scripts folder. And we're going to do something we've never done here before, and that's expose editor controllable variables. And that's via the keyword export here. So we'll save this. And now let's go look at our inspector. We see minimum level appeared, maximum level appeared, and monster types. Monster types is a tiny bit unwieldy for this. You have to specify the size of the array, and then you can choose what you want your monsters to be. So if we want both rat and bat, we have to set it to 2 and then pick 2 options. You can add quite a lot of customizability via these export variables here because they show up in the editor. And if you do things mostly by making scenes that you save, you can add properties like a color or a size or anything that you couldn't already control through the given nodes to you in Godot. Here we've clearly done something that Godot doesn't provide for us, which is our custom enemy types. But you can get creative with this. You can use the flexibility of the system. We are not going to be using min level and max level just yet because we don't have the concept of stats in the game. So I'm going to delete these, but actually I'm going to paste in the entire finished script and we'll cover what this does. This code is quite long, but it's actually pretty straightforward. So up at the top, we still have our export in Node 2D, the things that we had before. We have a signal, which you should now know about. What this is going to do is it's going to let our monster zone say I want someone to spawn an enemy out there. I don't know who's going to listen to this, but we want someone to spawn it. So we'll later need to connect something to this signal. And then we have the extents of our spawn zone. This is just an XY with height sort of thing. It just needs to represent a rectangle. And ready is mostly concerned with just setting up the zones. So you can read through this code if you want to. It's not super important. We're dynamically creating a trigger zone that's slightly expanded from the spawn zone. Then here we have something special, connect deferred. And the reason for this is because we are connecting to the body entered event. And when we connect to this, we're going to spawn enemies. But those enemies are also entering that same zone, even if their collision mask is not such that they should collide with that zone. So what we need to do is say this is connect deferred, otherwise we'll run into errors here. On a body entering, we're going to spawn enemies, and spawn enemies does exactly what it says. So we come up with a random number between 5 and 15, and then we just keep iterating over this, sample from our array, and spawn the enemy. And that's the signal that we talked about earlier. We are using two new functions that I have not defined. They're both in util, so let's go define them. They're not very difficult functions to understand. And one is sample array, which is going to just pick a random element of an array. It's one line of code, but it's nice to have this function. And the other one is a random int function. This is going to do the same thing as random range, but it'll return its result as an integer, not a floating point number. The final thing we need that we had done right here is we also ended up using tile size from constants. You may have seen me accidentally paste that in before. So we need in constants to just define our tile size, and that's just going to be 32 pixels. We have our monster zone scene, but nothing is using it yet. So let's add a node to our world map, and we'll call it monster zones, because this is where we'll put all of them. We'll eventually have many. We're just going to start with one. And then we'll instantiate in our monster zone that we made. Do not forget, if you did not already do this, to set what monsters you want to have spawn here. If you don't do this, you'll get an error about an array index being out of bounds. And then we want to set the collision shape to be whatever size you want the zone to be. So we can just go with something small for now. That sounds good. Do not just move this though into the world, because the monster zone's origin is going to be still in the center. So what we want to do is click the monster zone and prevent us from selecting the children. And that way we can just move the monster zone entirely somewhere. So let's try this out. Let's run the game and see what happens. There is a monster zone over here somewhere, but we don't know where it is. So let's do this. We'll click debug and then visible collision shapes. And now we'll see little blue circles and rectangles around everything. So you can see there's a very large rectangle here. That's that trigger zone that I was talking about that got dynamically created. You can also see the capsule shape, the circle shape. You can see this on the trees. And it's actually there on the water too, but it's a little bit hard to tell because the water's already blue. And I don't really have any other walls in the map that are easily visible for you to see them there. But yes, this is highlighting all of the collision shapes that we have. So we can tell that we are entering this shape pretty much as soon as we move anywhere in the world. And yet our monsters aren't spawning. Why not? The answer why is my favorite answer why code doesn't work, which is that we never added it, because it means that there's no bug with something that we did right. So what we have is in our monster zone, we have a signal and just nothing's listening to the signal. So we'll add that to gameplay, but we're going to do this kind of the same way that we did with billboarding, which is that we're going to add all monster zones to a group called monster zones. So let's go back to our monster zone. And in init, just or ready, anywhere really, we can add it to our group. So there we go. Now every monster zone is classified in this group, which will make it very easy for gameplay to be able to find them. So in gameplay, we're going to add this code to ready. It's going to look very similar to the code that we already had, and I'm going to fix some spacing problems here. So we're doing this, we're calling get nodes in group, everything that's in monster zones. And then for everything that's in there, we're going to connect spawn enemy to our own function, which we don't have yet, but let's go add that too. This looks about what you might expect. We have an enemy type, we have the position of where we want to spawn them. So we get the enemy information so that we can figure out which enemy it is, the rat or the bat. Then we simply instantiate the enemy, position it, and add it to our scene. So now let's test this out. And what we see here is that a bunch of rats and bats spawned. And we don't actually have controls to stop us from doing something like this, which is move out and into the trigger zone. And now we have a lot of bats and rats. We also see that we're not colliding with them. So about that first problem where they just keep spawning, you could add in controls yourself, something like an export variable that maybe is maximum number of monsters, and you could set it and keep track of it. We won't be doing that in this game. I actually kind of like having lots of monsters spawn because when they start chasing you, then you can use your special abilities and mow them down. Regarding the problem of not colliding with enemies, we're going to do something like what we did in Player Controller, which is to set the collision layer and mask dynamically directly in the enemy script. That way we don't need to go into each enemy that we had here and customize its collision manually by picking a layer and a mask. So let's go add in the enemy controller script. Unlike with the player, we're not going to attach it here. We could do that, that would certainly work, but we'll probably have lots of enemies and we might want to have different logic dynamically. So we're going to have gameplay controller assign it. But in order for us to even have the script in the first place, we have to make it. So let's make enemy controller, and I'm going to paste in quite a lot of code here. I've just pasted in a lot of code, but it's not really a whole lot of logic, even though there are more than 200 lines of code. So let's cover what's happening here. In general, what the enemy is doing is setting up timers to handle its AI and its firing logic. And timers are a new concept here, so let's cover them. Timers are something that Godot has that, just like a regular timer, will count down to 0. And then when it hits 0, it's going to fire a timeout signal. And then we have it restart back to whatever time it was set to. So in our case, we have the enemy trying to do different AI actions every 2 seconds. The way that this works might look new to you if you've never heard of coroutines before. So a coroutine has this yield operation, otherwise inside of an infinite loop, a while true loop. What's going to happen is that Godot will wait for this signal, and at that point it will yield processing time until this timer fires its signal, at which point it will recommence from where it left off and then set the wait time on the timer back to normal. There's another new thing I want to talk about, and this time it's with GDScript, not with Godot. It's the match syntax, which is similar to switch case. With switch case, you need a break or return statement in pretty much every case, unless you want to fall through to the other cases. But that's not very common. So what GDScript does with match is it assumes you're not going to want to fall through. So now all you really need is that one statement after each of your cases that you would have had. The other thing I want to focus on in this file, and this is not something new with Godot or with GDScript, this is just sort of linear algebra. We have this find player to evade, and then its implementation up here, AI evade target. And I want to just talk about what this does. So we have target position, which is the player, let's say. And then we have a vector drawn from the player to that target position. So that is like this arrow. Then what we do is we multiply that vector by 1,000. So we're basically saying shoot this off into the distance, like way higher than even what you can see in this picture, and have the rat pursue that point, whatever's up here. And that way, if the player moves, let's say like this, then that vector is going to be drawn over here. And now the rat is going to try to pursue this point. And that's just a nice way of coding evade player. And this is done very easily because we have this direction to, and because we can multiply vectors directly in GDScript. There are a lot of other pieces of code that I needed to modify in order to get this to work. And I don't want to show those because I don't think they're very important for the video. There are things like adding the player to their own group so that the enemies can find players. Eventually, let's say we had summons in the game, then we can just add the summons to that players group as well. And so the enemies find you based on a group name, not based on a reference to your player. But what we can see is the output of all of this. I still have the collision turned on, so we're looking at everything here. Projectiles hit the player and they hit the enemies as well, but they don't actually disappear yet. We haven't added that code. And we can see the enemies are pursuing us, they're evading us sometimes, and they've got different patterns that they can run every couple of seconds due to their AI logic. So everything's looking pretty good. In order for projectiles to hit their targets, we're actually not going to use signals here, which you might expect. We are going to use just this block of code essentially, and there's a bit to unpack here. One is this get slide count. When you call move and slide and it hits something, it will return how many collisions there are in the form of this get slide count. And all we care is that there's a collision. We don't care how many. So as long as it's greater than 0, then we're going to enter this body here. Now what we can do is we can get the 0th collision. So you can get however many, let's say there are 5 collisions, you can access collisions 0 through 4. And what we're doing here is called duck typing. And that was named after if it looks like a duck and it quacks like a duck, then it must be a duck. All we care about here is that this is quacking like a duck. It has a projectile hit function on it. And if so, we call that and we kill the projectile. So projectile hit is going to be on player controller. So we have projectile hit down here at the bottom. And for now, we're just doing nothing. So we don't have the concept of life in the game yet. We don't want our character to die when they get hit once, but we're totally fine with enemies dying when they get hit once. So in their projectile hit function, they just have a Q free, which is going to remove them. So I've turned off those collision fields that we saw. So now not everything's covered in blue. So we see projectiles getting absorbed by my player. That's because the projectiles are freeing themselves. And then as I shoot the enemies, they're all dying in one hit, making for a much easier game. There is one unusual thing that you might not expect from this, and this is actually a little bit hard to show off. So let's see if we can do this. We're going to set fireballs to be very slow again and live practically forever. And I'm going to see if we can replicate this. So the enemies are going to shoot at me, and they'll be very slow fireballs. And what I'm going to do is I'm going to move into the fireball from behind. And you can see that the fireball is not actually disappearing when I do that. So why is that? We have code in the projectile to make it hit my player. It moves and slides, and if it collided with something, then it should hit me and free itself. What's happening is that with the projectile moving away from us, on its physics tick, it's not actually colliding with us. So we are bumping into the projectile and then it's moving to create some space. So it hasn't hit us, and then we bump into the projectile and then it moves again. So what we would need to do is this same concept over in player controller, and it would look something like this. So we have the same move and slide in player. So that was us bumping into the projectile, and we need to check for collisions as well. We can also use duck typing, and we can check to see, does it have a collided with body function? If it does, then we can call that. And then we would need to define this collided with body function, and that would look very similar to how this looks, where we could call projectile hit and Q free back on the original body. So that's how we would get that to work. It's not very obvious if you don't have slow moving projectiles or they're not very big. So we could add this in. I will have this in the final code, but I'm not going to add it in this video. I hope you followed this video. I hope you learned something from it. I know this is really script heavy. The way that I suggest looking through this sometimes is by diffing the code you have with code that is in the folders that I provide. And that way you can see exactly what I might have added that you might not have in your code base yet. So if you go through that, I think it makes it a little bit better, but I'm hoping that you can still absorb some of the concepts from this video. As always, the code is in the Video 04 folder, and thank you for watching this.